Hello, my name is Todd Allman, and in this segment I'd like to provide a very brief introduction to natural language generation. Natural language generation is a subfield of computational linguistics, and people have been developing natural language generators for about 20 or 30 years now. And the reason they've been developing natural language generators is because there are so many difficulties associated with machine translation. So in this particular segment, I'd like to provide a brief comparison of machine translation and natural language generation. And in order to do that, I need to begin by reviewing the translation process. The translation process is generally broken down into three fundamental steps: analysis, transfer, and synthesis. In the first step, analysis, we analyze the source document to determine its meaning. In the second step, called transfer, we reconstruct that meaning using the target language's words, structures, their worldview, etc. And then in the final step, called synthesis, we synthesize the final surface forms. Now in a machine translation project, the computer has to perform all three of those steps. The computer has to perform analysis, transfer, and synthesis. But it turns out that making a computer perform analysis is extraordinarily difficult. In particular, three issues keep arising, and that is number one, automatic part of speech disambiguation; number two, automatic word sense disambiguation; and number three, automatic structural disambiguation. Now those three issues are all in the source analysis step. So computational linguists have begun developing natural language generators which perform only two of the steps, transfer and synthesis. And by performing only these two steps, we avoid the difficulties and complexities associated with automatic source analysis. There are two broad categories of natural language generation systems. The first one is called data to text, and these systems have been very successful. There are a number of commercial systems like this. These systems, they begin with a very large array of numbers. The numbers can reflect weather data, or financial data, or medical data, or any type of data. And these systems scan through these large arrays of numbers and pick out the most pertinent points. And then they write short texts summarizing the data in those arrays and pointing out the most relevant, the most salient points. A number of these systems exist. For example, Surgeon, which is a medical system; BabyTalk, which is another medical system; Fog and Sometime, which are weather systems. There are many systems of this type that are commercially successful. The second type is called text-to-text, and that name is a bit misleading. It's actually semantic representations to text, but to keep the name short and simple, we call it text-to-text. None of these systems have been commercially successful. There's KPML, which is being developed in Germany; Kant, which was being developed at Carnegie Mellon University; and then TBTA, which stands for the Bible Translator's Assistant. That's the natural language generator we'll be working with in this class, and the subsequent videos will describe TBTA very thoroughly. All of these take semantic representations which are manually developed, and then they produce text in multiple languages that convey the same meaning as the semantic representations. And for those of you who are interested, there's a conference, a biannual conference, called International Natural Language Generation. It's held every even year. So for example, there was one earlier this year in 2012. And that concludes this particular segment on natural language generation.